Hello everyone, welcome to Neelam tutorial. So in today's video, we'll be dealing regarding some of the important reactions of alcohol. The very first one we have Victor-Meyer test is the most asked question from alcohol. Next you have esterification reaction. So basically from this example has been asked along with its short explanation. Oxo-process, which is again the most asked question, and hydroboration technique for the preparation of alcohol is also one of the most asked questions. So let's move on. We'll be dealing the entire important reactions of alcohol one by one in the next 2-3 videos. Okay. So kindly view all the videos part by part so that you'll be able to answer the entire questions of alcohol. Let's move on for what is Victor-Meyer test. So basically, Victor-Meyer test goes in 4 steps. So if you remember the step, that will be easy for you. In the very first step, you need to treat the given alcohol. That is basically we have 1 degree, 2 degree, 3 degree alcohol. So in the first step, what you need to do is, in the first step, you need to treat it with phosphorus and iodine, P4 and I2. The first step, you need to treat the given sample of alcohol with P4 and I2. In the second step, we need to treat the whatever the product is obtained. In the first step, we need to treat it with AzNO2 sample. In the third step, whatever the product is obtained from step 2, we need to treat it with HNO2. How is HNO2 formed? So HNO2 is formed by the reaction of Na2 and NaNO2 and HCl. In the final step, we need to treat it either with NaOH or KOH, and a particular type of color will be formed. And by observing the color, like for primary, if it is 1 degree alcohol, the color those formed will be blood red coloration. If it is 2 degree alcohol, basically will have blue coloration. And if it is 3 degree alcohol, if it is 3 degree alcohol, there will not be any coloration. So just by visualizing the color, we can guess whether the given organic compound is 1 degree alcohol, 2 degree alcohol, or 3 degree alcohol. So let me explain you this one with the help of an example. Let's take an example of C4H10O. So what are the possible alcohol that I can make with it? So let me take 4 carbon, 10 hydrogen, so CH3, CH2, 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 and OH. So this is the 1 degree alcohol. This is basically, I can call it but and 1 all. All it is 1 degree alcohol. Okay. Next I can make it something like this. So what we can do is CH3, CH2, CH, CH3. And what I can do is I can put the OH group right in carbon number 2. And this is what we call butane 2 all. And the third one that I can make right from this one will look something like this. That is, there will be 1, 2, and 3 carbon. Other than that, I can put 1 carbon over here and the OH group right at this point. H3, H3, H3. So can name it as 2-methyl propane 2 all. So basically what you can know over here is this one is your, sorry, this one is your butane 1 all is your 1 degree alcohol. Okay. Butane 2 all is your 2 degree alcohol. Okay. And 2-methyl propane 2 all is your 3 degree alcohol. So basically, Victor-Meyer test will help us to identify the isomers of alcohol. That is 1 degree, 2 degree, 3 degree isomers of alcohol. Let's move on for it. How shall we go for the test or how shall we identify them? Now for primary, let me go for 1 degree, 2 degree and 3 degree entire one by one. For 1 degree alcohol, for 1 degree alcohol or primary alcohol. So what was the primary alcohol we were having? We were having CH3, CH2, 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 and OH. This was the alcohol. What is the first step? So I asked you to treat the given organic compound with the P4 and I2. Okay. So what will exactly happen is the alcoholic group, this alcoholic part will be replaced by iodine. So basically the compound those formed will be, it will be CH3, CH2, 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 and there will be I. Instead of alcohol O, there will be I. Okay. 1 degree iodoalkane will be formed. Next step, what was there is, whatever the product is formed, I need to treat it with AzNO2. Need to treat it with AzNO2. Okay. So what will exactly happen? This Az group will be taken away, will take away the I along with the liberation of AzI. And what will exactly happen? The NO2 will move and attach right to this carbon in order to form CH3, CH2, 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 and NO2. That is what we call nitroalkane. Whatever the product is formed, will again be treating it with HNO2. The next step, I'll be treating this component with HNO2. Okay, just a minute. Next step, I need to treat it with HNO2. So let me make it something like this. Okay, we have N, single bond OH, and we can make it as double bond O. Okay, so this is exactly HNO2 or nitrous acid, whatever you call it. Okay. So what exactly will happen right in this place is this double bond O will be taking away the two hydrogen from the primary carbon. So just beside this NO2 group, there we have this carbon and the carbon contain two hydrogen. So this oxygen will be taking away this two hydrogen in order to liberate H2O. What will come out? So H2O will come out. What will be the product from that? It will look something like this. CH3, CH2, CH2, C, double bond O, and there will be, sorry, double bond N. This entire group will come and attach there, double bond NOH, and here we have attachment of NO2 group. Okay, so this is what we call nitric acid, which is further being treated with NaOH, okay, in order to give blood red coloration. And here you will see blood red coloration. So just remember, let me again explain you this thing. The first step, it was being treated with P4I2. What happened? Iodine was added. The second step, it was treated with HNO2. And what happened? NO2 was added. In the third step, it was treated with HNO2. Okay. And the double bond NOH group attached right over here. And in the last step, NaOH was treated and we observed blood red coloration, which symbolizes that it is 1 degree alcohol. This symbolizes that it is 1 degree alcohol. Let me go for 2 degree alcohol. What will exactly happen in 2 degree alcohol? Okay. So here we have 2 degree alcohol. For 2 degree alcohol, let me again take the example what I took before. Again, I'll be taking CH3, CH2, CH, CH3, and here you have OH group. What I said, the very first step, what you need to do, we'll need to treat it with phosphorescent iodine. So what will happen? This OH group will be replaced by I. So here I'll have CH3, CH2, CH, and CH3, and here need to be iodine. Okay. Next, what will happen is this will be treated further with AgNO2. Further, it will be treated with AgNO2. Okay. Now, what will happen? This I group will be taken away by this Az. Along with the attachment of this NO2 will come and attach right in carbon number 2. Okay. So the product I will have will look something like this. It will be CH3, CH2, CH, CH3, and here you will have an O2 group. In the last step, you need to treat it with, sorry, second last step. Next step, what we need to do, we need to treat it with HNO2, which was something like this, and double bond O, and there was a OH group. Now, what you can visualize over here is the carbon containing NO2 group, attached NO2 group. This it has a one hydrogen, and this will be taken away by this OH group in order to liberate water, and the remaining N double bond O group will be attaching with the carbon. This group will come and attach with this carbon so that it will form something like this, a product like this: CH3, CH2, C, CH3. Here you have an O2 group, and right with it, there you have N double bond O. So this is what we call pseudo-nitrile. Pseudo-nitrile. And when it is further being treated with, when this is further being treated with NaOH or KOH, so at the moment we'll get blue coloration. So if it is being said that we have blue color uh, in the identification of alcohol by Victor-Meyer test, so you need to understand that it is 2-degree alcohol. If it says that we have Victor-Meyer, we have done Victor-Meyer test and we got blood red coloration at the end, we need to understand that it is 1-degree alcohol. Okay, so these are the things, these are the criteria that you must understand. So again, I'll make you know the first step we treated it with P4 and iodine. Second step we treated it with AgNO2. Third step we treated it with HNO2. And in the final step we treated it with NaNO2. Also, here was a formation of pseudonitrile. In the first reaction or treatment of 1-degree alcohol, we used to get nitrolic acid. This one is your nitrolic acid. This is your nitrolic acid. Now let's identify how to identify 3-degree alcohol. Let's move on for the next reaction for 3-degree alcohol. Okay. So what exactly was there? So we can have CH3, 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 and an OH group right there. So this is my 3-degree alcohol. The very first step you already know, we need to treat it with P4 and I2. Okay. So what will exactly happen? Again, this OH group will be replaced by I. So what will form? CH3, C, CH3, CH3, and here will be the attachment of iodine group I. Next, what we need to do? We need to treat it with, second step, we need to treat it with AgNO2. So what will happen? The I group will be taken away by this Az group, and the NO2 and the NO2 group will come and attach right with this carbon to form something like this: CH3, 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 and there we have NO2 group. Further, the next step you might be known that we need to treat it with, the very next step we need to treat it with sorry, just a minute. Last step we need to treat it with HNO2. And as we don't have any hydrogen being attached with this carbon, we don't have any hydrogen attached with this carbon. So the reaction, no reaction takes place further. No reaction takes place. And as there won't be any reaction when you treat it with NaOH, when we treat it with the NaOH, we won't be visualizing any color. So there will be colorless solution. So the very first what we have over here is first I treated it with before an iodine, second AgNO2, third HNO2, and then NaOH. And there was a colorless solution. It indicates that it is a 3-degree alcohol. So this is how we identify 1 degree, 2 degree, 3 degree alcohol by Victor-Meyer test. And it is one of the most important question from alcohol portion. Okay. Now let's move on for one of the easiest but important question from alcohol, that is your esterification reaction. We have esterification, esterification reaction. So what exactly is esterification reaction? So obviously the reaction in which ester is formed is known as esterification reaction. So in general, what you can say is when alcohol is being treated with carboxylic acid, that is R dash, it can be same or different. OH, that is this is your alcohol and this is your carboxylic acid. And when they are being treated with one another and they are being treated with in the presence of conc H2SO4, what will exactly happen is the H and OH group, this group will come out, okay, and there will be the formation of product, that is R O C double bond O R dash, that is what we call ester. And this reaction is known as esterification reaction. So basically the process of formation of ester by reacting alcohol and carboxylic acid in the presence of conc H2SO4 as catalyst is known as esterification reaction. Okay, so simple, any alcohol being treated with carboxylic acid in the presence of conc H2SO4 is known as esterification reaction. Easy on. Next we have oxo-process. What exactly is oxo-process? So oxo-process basically is an industrial process for the production of aldehyde and ketone. So in this process, we can prepare process used for the preparation of process used for the preparation of aldehyde and ketone. How? So by using alkene, so what you need is you need alkene and you need to treat it with carbon monoxide, CO, and hydrogen gas. So when alkene is being treated with carbon monoxide and hydrogen in the presence of cobalt tetracarbonyl, It generally will give you an aldehyde under high temperature and pressure. That's also the necessary condition for this. High temperature and pressure will get an aldehyde which is further being reduced. Catalytic reduction. We need to treat it pass hydrogen in the presence of nickel, platinum, palladium and hit it. So the aldehyde will convert into general alcohol. So basically what we can say is from alkene to aldehyde or from further reduction we can convert it into alcohol. So this process is known as oxo-process. So you might have the same question in aldehyde as well because the process of conversion of aldehyde to alkene to aldehyde. Let me explain you with this one with an example. Let's take CH2 double bond CH2 and we have carbon monoxide group CO hydrogen in the presence of cobalt tetracarbonyl. Okay, what will happen? What will form? So here you will have CH3, CH2, C double bond OH or CHO. Okay, which is further being treated with, or will have an aldehyde having one carbon being attached. The carbon will attach right at this point. The bond will break. The hydrogen will move to the other carbon. And further, what we need to do, we need to reduce it in the presence of hydrogen and nickel so that it will give you 1 degree alcohol. CH3, CH2, CH2, and OH. If there would be ketone, then it would give 2 degree alcohol at the last step. Okay, so the very first step you need to treat an alkene with a carbonyl group and hydrogen in the presence of cobalt tetracarbonyl or cobalt carbonyl as catalyst. It will give you aldehyde, which is further being treated with hydrogen in the presence of nickel to get alcohol, and this process is known as oxo process. The last one for today, that is your hydroboration reaction. Hydroboration, oxidation of ethene. So what we basically need, we need ethene, that is CH2 double bond CH2. Okay. And we need to treat it with diborane. Diborane is BH3 whole 2 group. Okay. What will it exactly give? It will give us trialkyl borane or tri over here we have ethyl group. So the bond will break. It will have one hydrogen. It will form CH3, CH2 and triethyl borane will be right there. Further, when we treat it with hydrogen peroxide, on the next step, we further treat it with H2O2. We generally get alcohol along with the liberation of boric acid, H3BO3. So let me just give you a technique. Sorry, in dihydroboration, there was the first you need to treat it with BH3 whole 2 and then with hydrogen peroxide in order to get alcohol. So these are the techniques basically for the preparation of alcohol. Okay. So one thing that I can explain you right in this one is where students generally get confused and you can have an easy technique for that is let's move on for it like this. If I have a compound like CH3, CH2, CH double bond, CH2 is also an alkene and I need to treat it with BH3 whole 2 that is diborane in the presence of H2O2. Okay. So what you need to put in mind is one thing that you can remember right in this step is simple. Don't get confused. Like if you are having confusion, like what type of alcohol will be formed. In this case, we can have 1 degree. If the OH attaches in this carbon, 1 degree alcohol. If the OH attaches in this carbon, it will be 2 degree alcohol. So what you simply need to put in mind is don't have a lot of confusion. Simply remember that you are adding water. Like just assume that you are adding water. How will it break? It will break as H plus and OH minus. According to anti-Markovnikov, hydrogen attaches to the carbon having less number of hydrogen. So H will be moving right here and OH will be moving right here, right? So basically it is going to give you 1 degree alcohol, right? So the product I will have is CH3, CH2, CH2, CH2 and OH, right? Or bute in all. Okay. So this is the product. I mean, what I'm simply trying to say, don't get confused. Simply what you remember is the way how you add water in alkene. Just keep in mind that you will follow the anti-Markovnikov rule. Whatever will be the product in the hydroboration technique as well. Okay. So thank you for watching the video. I'll be attaching certain questions right in the description box. So try to get the solution of those questions. And if you'll be able to do that, kindly attach the photos of the question in the comment section. And also, if you find the videos helpful, please do share it with your friends and don't forget to subscribe the channel. Thank you so much.